You know, right now, literally today, you can crack open your laptop, and within seconds, ChatGPT can write complex code for a brand new app. It can generate these stunning photorealistic images from scratch, summarize massive legal documents, and just completely automate exhausting business tasks. I mean, it feels like magic, right? But AI didn't just wake up one morning with these incredible powers. It definitely didn't happen overnight. It evolved through decades of hard-fought breakthroughs. We're talking about hitting massive walls and figuring out incredibly ingenious ways to climb right over them. So, welcome to this explainer. Today, we're going to trace the fascinating journey of artificial intelligence. We're going to look at exactly how we got here so we can finally understand where we're going next.
Okay, let's dive into this. We're breaking this timeline down into 6 crucial parts. 1. The rules era. 2. Machine learning. 3. Deep learning. 4. Generative AI. 5. Agentic AI. And finally, 6. Why it matters.
Starting with part 1, the rules era, which was all about manual programming.
So, rewinding the clock way back to the 1950s, the absolute gold standard of early AI was something called expert systems. Now, the key concept to understand here is that everything, and I mean everything, was done manually. There was no machine learning yet. Human engineers and domain experts had to physically write out every single rule and instruction the computer would ever use. They built these systems to handle very specific tasks, things like early medical diagnoses, processing bank approvals, playing chess, or automating factory manufacturing. And honestly, at the time, this was completely revolutionary.
To make these expert systems actually work, engineers relied on really rigid, step-by-step logic. We call this if-then logic. So, for example, a medical system might be programmed so that if the temperature is greater than 100 degrees Fahrenheit, and a cough is present, then output possible flu. The machine wasn't thinking at all. It was just blindly following a highly structured flowchart that a human being painstakingly typed into it.
Imagine trying to write a rulebook for every possible situation in life. It's completely mind-boggling, but that is exactly what early AI engineers had to do. Think about it. If a patient came in with a temperature of 99.9 degrees instead of 100, and the system didn't have a specific rule for that exact decimal, it wouldn't know what to do. The engineers faced this literally impossible task of trying to anticipate every single variable in the real messy world and hard-code a rule for it.
So the crucial point is that this manual approach eventually hit a massive brick wall. It's just impossible to write rules for every scenario. What's worse, these systems couldn't learn from their mistakes. If they got something wrong, a human engineer had to go in and manually update the code. They completely froze up when dealing with any kind of uncertainty, and if they encountered a brand new situation that wasn't already in their database, they just failed. The technology had basically gone as far as human typing could take it.
And this brings us to a really pivotal moment in technology history. The AI community was stuck because the real world is messy, it's unpredictable, and it's full of these gray areas that rigid if-then statements just can't handle. So, if rules couldn't solve every problem, what came next? How do you get a machine to understand a world that is way too complex to be written down in a rulebook?
That brings us to part 2. Machine learning, and the shift to data.
The answer to that problem was a total paradigm shift, and the fundamental difference here is incredibly powerful. In the rules era, as we just saw, humans programmed manual instructions, but in the learning era, humans stopped trying to write the rules. Actually, scratch that. They didn't just stop, they completely flipped the script. Instead, they started feeding computers massive amounts of data. The paradigm shifted from programming logic to finding patterns. The machines were now analyzing data and effectively writing the rules themselves based on what they observed.
It's like this. Instead of teaching a child every single traffic rule one by one, like stop at a red octagon or yield at a yellow triangle, imagine just showing them thousands of hours of driving videos until they naturally recognize the patterns of how traffic flows. That is exactly how supervised machine learning works. You feed a computer millions of emails labeled spam and not spam, and eventually it figures out the pattern all on its own. And the best part, the more data you feed it, the more accurate it becomes.
Moving on to part 3, deep learning and the 2012 breakthrough.
Okay, so machine learning was great, but it still had limits when dealing with ultra-complex data. Things like high-res images and audio. Before 2012, neural networks, which are these computing systems inspired by the brain's neurons, well, they existed, but they were pretty basic. Then came the 2012 ImageNet competition. Researchers trained a deep neural network, specifically one called AlexNet, on millions of labeled images. Because they use these powerful gaming processors known as GPUs to crunch all this data simultaneously, The AI's ability to accurately recognize objects absolutely shocked the global AI community. Boom. Everything changed.
This 2012 breakthrough is what took AI out of the research labs and put it directly into your pocket. Because the AI can now process vast, complex patterns, it unlocked the ability for your phone to instantly recognize your face. It's literally the reason voice assistants can actually understand your speech now, why Google Translate works so seamlessly, and how Netflix knows exactly what show you're going to want to binge next. It laid the foundation for autonomous vehicles and advanced disease detection in healthcare scans. AI was finally incredible at recognizing the world. Which leads us to part 4. Generative AI, the Transformer Revolution.
But here's the thing. Just recognizing the world wasn't enough. We wanted AI to generate entirely new things. And the engine behind that massive leap was the Transformer architecture. Introduced in 2017, the Transformer was a revolutionary way for neural networks to process data. Instead of reading text word by word from left to right, Transformers look at an entire sentence or paragraph all at once. This allowed the AI to understand the deep, complex relationships and context between words much better than any previous model. And this brilliantly illustrates how we got to today, because this architecture is literally the T in ChatGPT. It laid the groundwork for everything we use right now.
Which brings us to a date that fundamentally changed the internet forever. November 2022, the launch of ChatGPT. Because it was built on that Transformer architecture, it could understand human language with shocking fluidity. It didn't just give you a list of blue links to a website, it talked to you. It answered questions, it brainstormed, it wrote full essays. It became one of the fastest-growing technologies in human history, hitting 100 million users in just 2 months. Unbelievable.
The generative era has fundamentally changed our relationship with computers. We went from machines that could recognize a cat in a photo to machines that could generate an entirely original photorealistic image of a cat riding a skateboard on Mars. AI now generates highly complex computer code, it composes original music, builds entire presentation decks, creates videos, writes emails, drafts legal reports, and brainstorms business ideas. This era has shifted how millions of people work, creating entirely new workflows basically overnight.
So, part 5. Agentic AI. What happens next? Well, if generative AI was all about giving the machine a prompt and getting a result, the next frontier is giving it a goal and letting it act. We are actively moving into the era of agentic AI. Today's AI models are moving way beyond just chatting, they're becoming agents. They can reason through a problem, create a step-by-step plan, and actually use digital tools. They can browse the live web, interact with software APIs, and even work together with other AI agents to complete complex, multi-step tasks. Soon, you won't just ask an AI to write an email, you'll ask an AI agent to research a client, draft the proposal, access your calendar, and schedule the meeting entirely on its own. Autonomy is for sure the next big wave.
And finally, part 6. Why it matters. The big takeaway.
Taking a step back, this whole historical journey beautifully tells the story of human ingenuity. Every single generation of AI solved the exact problems that the previous generation just couldn't handle. In the rules era, machines followed our strict instructions, giving us basic automation, but they couldn't handle complexity. So we moved to the learning era, where machines learned patterns from data, giving us this deep recognition of the world around us, but they couldn't create. So we evolved into the generation era, where machines now create entirely new content, giving us boundless creative potential. And now, we are stepping into a future of autonomous agents. This journey has transformed healthcare, revolutionized finance, and completely rewired our everyday lives. Understanding this history doesn't just explain the past, it prepares us for the future.
Which leaves me with one final, fascinating thought for you to ponder. Looking back at this incredible timeline, from the painstaking if-then rules of the 50s to the magic of machine learning, that massive leap of deep learning in 2012, or the creative explosion of ChatGPT, which AI breakthrough do you think changed the world the most? It's a massive question, and honestly, the answer is continuing to unfold right in front of us. Thank you so much for joining me on this explainer, and hey, keep your eyes on the horizon. The next breakthrough is already on its way.